Alright, in this video we're going to look at how to create an exponential regression. Now notice first of all in this problem it tells us that it's exponential. It says a conservation agency tracks the sea turtle population by counting the number of nesting sites where the turtle lay their eggs. The table shows the numbers of nesting sites for several years since 2001. The data can be modeled by an exponential function. Now they've given us a table here. Notice our x values are on the left, our y values are on the right. What we'll need to do if we want to create an exponential function that mirrors one of these that you see listed is we're going to need to go ahead and put it into our calculator and create what we call an exponential regression. Now the first thing that we do if we want to do that, I'm going to type first, we're going to go to stats. So I'm going to get my calculator and walk you through each step. So if I take my calculator over here and I click on the button that says stat right here underneath delete, it's going to take me to a list and it says edit calculator or calculate our test. I'm going to stay on this first menu, option 1 where it says edit, and I'm going to hit the enter button at the bottom of my calculator down here. So now that we went to stats and we hit enter on the first tab that said edit. So notice right here, option 1, edit. It's going to pull up a table. And so we're going to use this table. The left one is going to be our x values, that's over here. And the right one is going to be for our y values that are on the right side. Now some of you may be looking at it going, you know what? Well, it doesn't say y right here, it says n of x. And just remember that n of x or f of x, a lot of times they use f of x, is the same thing as y. So I'm just going to put an arrow. It is y. So these are my y values. These are my x values. So I'm going to go ahead and type in that first column, each one. Now after I put in each number, I will need to hit enter. For instance, I'm going to type in a 1. And then I'm going to go down here and hit my enter button. Now when I do that, it saves that entry in there. Notice it has a 1 in there now. And I'm going to put in 2, the next one, 2, enter. And 3, enter. 4, enter. 5, enter, 6, enter, and 7, enter. And notice now, this table that I have right here, it goes from 1 to 7, and this one goes through 1 through 7. So now we just got to put all of our y values from top to bottom. So I have 4, 6, 1, 2, 5. I want you to notice that I'm not going to put a comma. If you try to put a comma, if you were to try to put a comma or any type of digit in there other than a number, it's going to give you an error. So just 4, 6, 1, 2, 5. Now if that was a decimal, I would put a decimal, but it's not a decimal, it's just a comma. So I'm going to click down, or you can hit enter either way. So 37944, hit enter. 40513, hit enter. 29368, 34082, 31746, and 27691. So notice I have the same amount of data entries on both sides. So you know you can see my ordered pairs from left to right all the way down to 7 and 27691. I'm going to go to the next step now. So the first step was stats. And then I'm going to put second, I'm going to put enter data x comma y. And then the third step, which is what we're on now, I'm going to hit stat again. So I'm going to write the word again, stats. So once you click stat, this time you're going to click to the right and go to calculate. So I'm just going to write that in here, each one, so calc. And then you're going to go down until you find exponential regression. And notice that it's option 10. So down here at the very bottom it says EXP REG. So I'm going to write that. You go down to EXP REG. And that stands for exponential regression. Now once you're there, you hit enter. And after that, it's going to take you right here to this list. It's going to say X list and Y list. Well, we already did the X's in the L1 column. And then we did the Y list, which is our L2 column. It was all of our Y values on the right column. So what I want to do is click down until it gets to calculate, because it's going to calculate it for us. So I do want to put right here that you do got to press enter after selecting exponential regression. And then after that, let's see, let's actually put another step. Let's say step 4. Select calculate. All right, now I'm going to hit enter on this, and you're going to see that it's going to give me some values. Now, whenever we write an exponential equation, first of all, I want you to remember that it is f of x is equal to a times b to the power of x. And there's a couple things. First of all, a is the y-intercept, so I'm going to write that right here. Y-intercept, or you could also see it as your initial value. B, on the other hand, is the growth or decay factor. And the X just stands for the time that has passed. Sometimes it'll ask you to make a prediction, so you'll need to know these things. And you can note this down if it helps you. Now what I want to do is notice they gave me an A value right up here at the top, and they gave me a B value right underneath. So I'm going to write what they have given us so far. So for my A value, so for A, my initial value or my y-intercept, I have 46771.5408. For my B, my growth or decay factor, in this case it's going to be a decay factor because it's less than 1, and that one is going to be 0.92906. Now typically I just write 3 to 4 decimal places. 3 decimal places is normally enough, but we're going to look and we're going to see how many decimals we need to round it to get it to match our answer choices. And then for the time, the X, notice they didn't give that to us, it just has a caret symbol, and then X, we just put this to the power of X. And what we want to do now is we want to find the answer choice that looks closest to what we have right here. And that's going to be our function. So I'm going to move this out of the way. So if I'm looking at this, notice this number is 46771. Move it up a little bit. This number is 46771. If I look right here, this one has 25956. So it's not A. This one has 46797.94. This one has 1.08. So it's not that one. This one has 0.93. It's not that one. So the closest answer to what we have here, 46771, and then 0.929 is going to be B. So this just shows you if it were to be multiple choice, what you would pick. Notice they did some rounding, right? The 0.929, that 9 would tell us to round that 2 to a 3. So they round it to the tens place. This one right here is off a little bit, 46771, but it's really close. And it just depends on the values, the type of calculator they use, because it's going to do some rounding. So that is the correct answer, and that's how you find an exponential regression. Now, while we have solved this correctly, I want to go ahead and move it up, because sometimes a problem not only will have you give the equation, but it'll tell you to solve for something. So, for instance, notice that when we were dealing with this table, I'm going to move it down. This was talking about the number of years since 2001, and it only goes up to 7. Sometimes you'll have a question, and it'll say something like, what is the number of nesting sites after 15 years? So let's say this was a 2-part question. And in other words, when it comes to nesting sites, that's our Y value. And it wants to know what is the number of nesting sites after 15 years. In other words, they're giving us the X value. This should be in our X column of the table. The problem is this table only goes up to 7. So we don't know what it is at 15 years because it stopped at 7. Well, there's two ways we can answer this very easily. One way is we can put it in the calculator using this equation, and we can go ahead and evaluate it. In other words, I can take what's after the equal sign right here, put it into the calculator, and just substitute 15 for the x, and I'll have an answer. So I'm going to show you that way first. So I'm going to call this the calculate method. So I'm going to put calculate, and we'll write our answer right underneath. So we're going to check it for 15 years. So to calculate it, I'm simply going to pull this up. I'm going to get out of here, and I'm going to type in what's on the right side of my equal sign. So I have 46771.5408 parenthesis, and then I'm going to put my decay factor 0.92906 close parenthesis. I'm going to hit the caret key, the little up arrow, to put my power, but instead of an x, I'm going to go ahead and I'm going to put 15 years, right? Because our goal was to find what is the number of nesting sites after 15 years. So once I put that in there, I'm going to hit enter. And notice that it tells me that there's going to be 15,510 nesting sites. Now, I'm going to write this number out, 15,510.9. I'm going to round this to the nearest whole number because you can't have partial nesting sites. So I'm going to underline my ones place, circle my tens place, and that 9 tells me that I got to raise that 0 to a 1. So we're actually going to have 15,511 nesting sites. So if it asks me to make a prediction of how many nesting sites for a future amount of time, I could use this equation, just like you've seen in the calculator, to make that prediction. On the other hand, we could also use the graph and table to give us the answer. And I tend to like the graph and table. I'm going to show you what I mean by that. I'm going to go ahead, and we're going to get the same answer. It's still going to be 15,510. But watch how I'm going to do it. Instead of me typing it into the calculator and hitting enter and putting the x as a 15, I'm just simply going to type in this equation we have. So notice it already has y equals y1. That stands for f of x. So I'm just going to type in the equation now, 46771.5408 parenthesis 0.9, so 0.92906 close parenthesis. I'm going to hit the caret, and I'm going to put an x in there. So I'm going to hit this x button right here. So 0 and 6 and close. All right, so now we can see that it is exactly the same. So if you look right here, it says at 15, we have 15,511. So whether you use the calculator, use the equation in the calculator to calculate it, or whether you graph it and go ahead and pull up the table so that you can see what the value of y is going to be at 15 years, you can use either one, whatever one you think is easiest. I like graphing it and just scrolling through the table. But if you needed to go down to when at 250 years later, right, it would take a long time to scroll down to 250. So in that case, I would just go in and put it in the calculator and calculate it and come in and substitute 50, that year for the x. But if it's a small number like 8, 10, 15, 20, right, it doesn't take but a second to scroll down through your table and find when x is equal to that value, and then find the relevant y value that goes with it, which is your output. So hopefully this video helps you to know how to create an exponential regression, and you now know how to also evaluate a situation with that expression when given a number of years.